recording another video now from where the first one left off. And so this time we're going to look at the same motion. Whoever was doing this moving is now going to be graphed on just a different graph. The same motion on a different graph. I'll show you what I mean by that. So before, what we did was we made a graph that looked, vaguely like this. And it was up to 10 seconds here. 5 seconds was in the middle. And this was time, just to repeat. And we had position on the y-axis. That's what we had last time, position. This time we're going to have your velocity, just like with the motion detectors. Remember, we had velocity graphs too. So velocity, and this is in meters per second. 0, this might be 2, 4, 6. This would be -2, -4, -6, -8, -10, -12, -14, -16, all the way down here. Okay. So let's just go back. Help me out here. For the first 3 seconds, looking back at the first graph, how fast was I moving? Right, and what's the slope during that time? 0. So my velocity for the first 3 seconds is also going to be 0, because I'm not moving, which looks just like the other graph, but be careful. It's about to not look like the other graph. So far it looks like I'm copying, but I'm really not. This is a 0 because my speed was 0. My slope was 0. And then for the next seconds, from 3 up until 9, that's where the graph was red. I was definitely moving, and we already figured out how fast I was moving. How fast? 2.5 meters per second, right? So I went from 0 to 15 meters, 6 seconds. 6 into 15 is 2.5. 2.5. If that's 2, I'm going to have to zoom in, guys. So if that's 2 meters per second, and that's 4, 3 would be right in between, and 2.5 would be right in between that.
Yeah.
So right about there would be 2.5 meters per second, and my speed for the next 6 seconds is steady. And that was the line that was red before. I'm going to make it red again, just so you can remember that they go together. And now that graph doesn't look at all like the graph above it, but it's saying the same thing. It's saying that my speed was a constant, not changing, 2.5 meters per second, the slope of that line. And then, suddenly, at 9 seconds, I turned around and ran back at 15 meters per second. I ran back very fast at 15 meters per second, the other way. So for that last 1 second, from 9 to 10, way down here at -15 meters per second, right down here, for the very last second, this was my speed, which I made blue before, so I'll make blue again. So in other words, at 9 seconds, I immediately shifted, zip, from going forward at 2.5 meters per second to going backwards at -15 meters per second, and that's when the graph ended. These two graphs look very different, but they're saying the same thing. Just look at that for a minute and see if you can see what I mean. They look so different, but they're saying the same thing. Okay, so again, to review just quickly, in a position graph, I didn't go anywhere. Then I started to move. Then I came back to wherever I started from. So here, my velocity is 0. Then I started to move at a steady 2.5 meters per second. And then I ran back at a very fast 15 meters per second, but the other way. Now, I want to show you where the area comes in, because this is the kind of a cool part. I think it's kind of cool, yes.
Is it like?
Sure.
Okay. So I think the area is going to be like, you can see this. Yeah. So like I think the area would be like right now.
Like, what shape is this?
Like an L.
What shape is that? I mean, what would you call the shape?
Like a rectangle.
It's a rectangle. It's a rectangle. It's like a shoebox. And how high is that rectangle? 2.5 watts. 2.5 watts. Look carefully. Yeah, and what are the units of the velocity? Meters. So it's 2.5 meters per second high. This is 2.5 meters per second high. A little rectangle that's 2.5 meters per second high. And how wide is the base of the rectangle? How wide is it? From 3 to 9. How far is that? 6 what? 6. What are the units? Seconds is right. 6 seconds. When you find the area of a rectangle, what do you multiply? What's the formula for the area of a rectangle? Length times width or base times height? Yeah, base times height, length times width, same thing. So if you multiply length times width, which in other words is 2.5 meters per second times 6 seconds, what happens to the seconds, guys? Yeah, it's like wobbing. The seconds go away, and what's the number 2.5 times 6 equal to? What's 2 times 6?
12.
And what's a half of 6?
3.
So what's 12 and 3?
15.
15, and the units are meters. And guess what? That's how far we went in those 6 seconds. It's the same as going from 0 to 15 up here. It's the area there. And I'm going to ask you, see if you can do this one in your head. What's the area in this skinny little rectangle? What's the area in here? Is it plus or minus, first of all?
No, minus.
It's minus. It's 1 second wide. Alejandro, would you like to stay for the remainder of the class? Thank you. You know what to do. It's 1 second wide, just 1 second, it's puny second wide. And how tall is this?
14.
Close.
I can't. It's like 14.
15 and a half.
Well, right on 15, I think it was.
Oh, I thought that's like 1/2, but it's a meter per second.
Right. So this is actually negative 15 meters. The area in here is negative 15 meters, which is because you went back from here to here, you went backwards 15 meters. From 15, from 15 over here back to 0. You went negative 15 meters. And that's what this area is. That's the connection between the two graphs. And I think, this is all, of course, brand new to you guys, but as we look at these things together over the next few days or weeks, this will start to become like, oh yeah, these are good tools. These are good tools to understand motion. At least that's my hope.
Are you posting this on the?
Yes, first of all, Samira, I don't know if the recording